exercise, we're going to determine the oxidation number of the sulfur in different compounds. So we are asked to determine the oxidation number of sulfur in two molecular species that are the A and the C, in the elemental form that is B, and in two substances containing ions that are D and also E. So in each species, the sum of oxidation number of all the atoms must equal the charge on the species. So here, the oxidation number, the total oxidation number is 0. This is a neutral compound, as well as this one, and as well as this one. Here, this compound also is neutral. Here, the total sum of oxidation number is -2. Okay, so we will use the rule outlined previously to assign the oxidation numbers. So, first of all, when bonded to a nonmetal, hydrogen has an oxidation number of +1. As we can see here in exercise in the example A, we have H2S, and hydrogen is +1. So, because H2S is neutral, the sum of the oxidation number must equal to 0. So, if we have this is equal to +2, that means that the S is going to be -2. So here we have the equation 2 times +1, because we have two hydrogens and each one is +1, will be +2 plus X is going to be equal to 0. And if we need to rearrange this equation to have the value of X, we need to subtract 2 in each side, and X is going to be equal to -2. So here in the first one, sulfur has an oxidation number of -2. On B, this is the elemental form of sulfur. So the oxidation number is going to be equal to 0. So also, because in this way, all of this is going to be 0, so each one is going to be also 0. So in the elemental form, sulfur, the oxidation number is 0. When we have the SCl2, this one is a binary compound, and chlorine is from family 7, and all from family 7 has an oxidation number of -1. So because of that, X is going to be the oxidation number of sulfur. We have 2 chlorine in this compound, so it's 2 times -1, that will be -2. So this is going to be X minus 2 is equal to 0. So if we want to arrange the equation in a way that we have the X by itself, we need to add 2 at each side, and that will make the X is going to be equal to +2. Okay, so in that way, here the oxidation number is +2, here is -2, here is 0. Let's go to see the example D, sodium sulfide. In this one, the sodium is from family 1, and is going to have a oxidation number of +1, and we have 2 sodium. Okay, also this is going to be the ion, okay, which in this case the oxygen is -2, and we have 3 of them. So that will be 3 times -2 is going to be -6. The sodium is +2 because we have 2 of the sodium +1, and the X will be the oxidation number of sulfur. So in that way, it will be 2 minus 6 will be -4, plus X is going to be equal to 0. To rearrange this, we will add +4 in each side. So that means that the sulfur will have an oxidation number of +4. Okay, we have this 2 is because of the sodium. Each one is +1, so we have 2 of them. 2 times +1 will be +2. We have 3 oxygen, and each oxygen has an oxidation number of -2. We have 3, so it's going to be -6. Plus X, that is the oxidation number of sulfur, is going to be equal to 0 because the net oxidation number of the whole molecule is going to be 0. Okay, and we rearrange this to have the value of X, and that's going to be 4, +4. In the E example, we have SO4 -2. And as we mentioned, oxygen is -2. We have 4 of them, so this is going to be -8. But now it's going to be X minus 8 equals to -2. Remember that here the ion has a -2 charge. So that means that this must be equal to -2. So to do that, this X must be a +6. +6 minus 8 is going to be -2. And that's the oxidation number of sulfur in this ion of sulfate.